data research design is to observe mean differences across two or more means, as well as measure the variable at multiple levels. In essence, the t-test gives a measure of the difference between two sample means in relation to the overall spread. When comparing two or more means, different vocabulary is utilized to describe the treatment being measured on the sample. Instead of independent variable, we use the word factor to describe the variable being changed in the experiment. We use the word level to describe the possible values of a factor. For example, a researcher may want to test how wearing different perfume scents affects test scores. Subjects can be asked to wear the perfumes at different amounts, like 4 sprays or just 1 spray. She may also want to see if the effect increases over time, so time may be measured, let's say 30 minutes versus an hour of wear time. These are various levels testing one factor, the perfume scent. A large amount of data can be observed and compared to one another using a t-test, and this allows researchers to obtain more information from their studies.
I have a pretty difficult test today. I wonder which perfume I should wear.
Well, that is something that can easily be tested with a repeated measure t-test. I just need to get some volunteers. Well, I'm sure I can find someone around. Well, I hope I do well on my stats final. Okay, now I just wait 30 minutes. Alright, just 1 spray and wait an hour, and then I go take my math final. Aw, dude, come on. I thought I had it. Yes, I knew I had this one in the bag.
There are two kinds of t-tests that researchers may use to observe the effect of a treatment on a sample in order to make predictions about the population. These can be done on studies that compare both two means and studies that compare 3 or more means. The first type is an independent t-test, which compare two means based on independent data. Data measured in these research designs are from two separate groups, testing one factor. In short, data collected from different groups of people. The second type is a repeated measure t-test, which compares two means based on related data. These research designs have one sample that is measured under different conditions in order to test the factor. In other words, data from the same sample of people.
For an independent t-test, the data could come from two completely separate groups of participants or come from the same group of participants. The way that an independent t-test is calculated is using the formula where the sample mean is subtracted by the population mean, all divided by the estimated standard error. However, if you want to find the difference between two sample means and get the t-statistic for that, you would use a formula where the sample mean difference minus the population mean difference is all divided by the estimated standard error. In a repeated measured t-test, an individual from the same sample is measured 2 or more times.
We initially learned variance as s squared equaling to the sum of squares divided by your degrees of freedom for a sample, degrees of freedom equaling n minus 1, and the sum of squares equaling the sum of your x values minus your mu value squared. For pooled variance, when you have independent samples, you're going to use your sum of squares of your first sample plus your sum of squares of your second sample divided by your degrees of freedom from your first sample plus degrees of freedom of your second sample. We initially learned standard error as sigma divided by the square root of your population size. This becomes the square root of your variance pooled divided by your first population size plus your variance pooled divided by your second population size. In Chapter 11, we learned that the mean of the difference of scores is equal to sigma difference of scores. So to find this D value for all of your scores, you subtract your pre-treatment X values minus your post-treatment X values. And that will give you the difference between your means. Then you sum all of your means and divide them by the population size. This then translates your t-score formula from m minus mu over your standard error to t equals md minus mu over your standard error.
Hypothesis testing is also very different for repeated measure and independent sample t-tests. For independent sample t-tests, both population means are compared to each other. For a two-tailed test, this would look like the following. The null hypothesis is mu1 minus mu2 is equal to 0. Or in other words, both population means are the same. The alternative hypothesis would be mu1 minus mu2 is not equal to 0, or that there is a difference between each population mean. To perform a repeated measure hypothesis test, a new measurement is needed. The difference in the two sample measurements, or the mu-d, is used for repeated sample hypothesis tests. For a two-tailed test, the null hypothesis would be that the mu of d is equal to 0. In other words, there is no difference between each measured sample treatment. The alternative hypothesis would be that mu of d does not equal 0, or that there is a difference between the treated and untreated sample groups.
My name is Susan Donnie, and I did the perfume skit as well as explained definitions for repeated and independent t-tests and ANOVA research designs.
It's Warren Sartor, and I did the difference between independent sample and repeated measure hypothesis testing.
My name is Fernando Lopez, and I did how the participants are selected and measured throughout the different t-tests, and I put the video together.